Welcome to another Dive in 5. I'm Rebecca Ore, Math DRT, and today we're going to be looking at first grade composing and decomposing numbers to 100. Let's start off with this first task. Pause the video and complete it on your own or with a partner or team. Think about, as you're solving, what skills and prior knowledge, including tools, do students need in order to be successful with this task? Time to check your answers. Hopefully you used your understanding of equality and place values to successfully identify which equations were true and which were false. When you solved this problem, did you think about what skills and prior knowledge would be needed to solve this task? What do students already know? What do they need to learn? Did any of these tools or strategies come to mind? These are all things that we're going to want students to understand by the end of this unit so that they can successfully solve tasks such as this one. Now let's take a look at the progression with BEST. Here's what students were expected to do in kindergarten. Here's what they're expected to do by the end of first grade. We're going to be focusing on reading and writing numbers to 100, composing and decomposing two-digit numbers in multiple ways, and writing the numbers that is 1 more or less, 10 more or less than a given two-digit number. We want to prepare them in all ways for these next skills that they're going to need to know by the end of second grade. In order to build conceptual understanding of place value, instruction should include the use of proportional and non-proportional models. Let's take a look at these different types of models and how and when we could use them with our students. First, let's take a look at proportional models that are groupable. These models can be put together and taken apart. So, when we build with snap cubes, we have individual snap cubes that make those trains of tens. But we can also take those trains apart so we have individual snap cubes. So think about pre-group base 10 models. Typically, we start here, but we don't want them to start there quite yet. They need to build a foundational understanding of a group of 10 and 10 ones make 110. Think about how difficult this vocabulary can be and confusing. If we start with those groupable models, they should have more success. Pre-group models can't be taken apart. They are also the same physical size or proportional. One base 10 rod is the same size as 10 unit cubes put together, but I can't take that 10 rod apart. If you look at the beans on popsicle sticks, it was a groupable model until the beans were glued onto the sticks and now they can't be taken apart. So it's a proportional pre-grouped model. Now let's take a look at the third type of model. These are non-proportional models and are more abstract. Take a look at the place value disk. If I count out 10 ones disks, all 10 disks would not be the same physical size as the one 10 disk. Think about how confusing this can be for students. 10 pennies are definitely not the same physical size as one dime. And in fact, a dime is smaller than a nickel, but worth more money. We want students to have enough time working with the groupable and non-groupable models that we just went through before they move to these more abstract non-proportional models. Okay, so another skill we're going to want students to be able to do is decompose and compose numbers in multiple ways with objects, drawings, expressions, and equations. So you could do something like this. Show them a two-digit number and have them model that with any sort of physical concrete model. Most likely, they're going to put 3 tens and 6 ones. As students are building these models, go ahead and write the expressions on the board so that they can make the connections between the models and the equations. Then, once students build this, practice trading out a 10 for ones so that they can see the additional ways to represent 36. 2 tens and 16 ones. One at a time, they trade out a base 10 block and for more ones and can see all the different ways that they can represent a two-digit number like this for 36. Once you have all equations written down, ask students what they notice about the different equations that represent all the ways to show 36, for example. Hopefully they see that all equations still have a value of 36, even when the number of tens decreases and the number of ones increases. Another skill is identifying 1 more or less and 10 more or less. As with all concepts in this unit, we want to focus on the place value, not addition and subtraction equations. So instead of equations, use number lines like this one to reinforce the idea of 1 more and 1 less. Also, make connections to the hundreds chart like this one. Ask students to describe patterns that they see in the digits as numbers increase or decrease by 1 and 10. What happens to the number in the tens place when you add 10? What happens to the number in the ones place when you subtract 1? You can also pull out sections of the hundreds chart and have students identify 10 more, 10 less, and 1 more. Take a look at the colors in the chart that I've made. Do these colors help you notice what is happening to the different values? Make use of color in your instruction too to help students recognize and explain these patterns when counting 1 or 10 more or less. Now let's talk misconceptions. One misconception is that students will reverse digits. And that happens until students solidify that the placement of the digits matter and that each place has its own value. What can help with this is using place value maths, tools, proportional and non-proportional. You can have students represent each two-digit number and compare how they represented each value. Another misconception is when students start reading and writing numbers in different forms. Some students may again forget that the digits represent different place values. If you see this, have students go back to those base 10 blocks and place value maths to model the number and describe the values correlated to tens and ones. Here you see the concrete tools that can be used, the representations students will make when drawing models, and the abstract thinking, which are those numbers and symbols that we put down on paper. Make sure that you're making connections and that when students build with base 10 blocks, they could also be drawing the quick picture alongside the concrete model so that they make connections between these two. And as always, remember, based on students' understanding of place value, they may need to go back and forth from island to island, and that's okay. That's all for this Dive in 5. We'll see you on the next one.